Alrighty, how's it going, everyone? I'm back home for this video. I don't know if anyone saw yesterday's video. I was at my girlfriend's house, so recording was a little bit different, but today I'm back home. I just got a cat today, a second cat, so my girlfriend's here keeping an eye on the cat, making sure it's all good. So I'm probably going to make this video a quick one because of that. But it is 6:53 p.m. Sunday, August 3rd. I believe this makes the 70th video, which is crazy because it feels like I've only done 10 of them. But I guess time truly does go by ridiculously fast. We're gonna go ahead and move on to greedy. So today we're gonna be doing problem 53, maximum subarray. So let's see. Given an integer, array nums, find the subarray with the longest sum and return its sum. Okay. Let's see. We have 4, 3, 5, 1, 6. Okay, so obviously, because this is the greedy, this should just be a linear path. I'm just trying to think of the greedy mathematics for this. I could probably set up some sort of system where if it goes under 1, which is sent to 0, the reason why is the first one will always be a positive and the last one will always be a positive. So we can always just ignore the negative. And the thing is, if the previous one doesn't cancel out with the, like let's say like a position 1 is a positive, position 2 is a negative, and position 3 is a positive. If position 1 is get canceled out by the negative, then we use that for our solution. So I'll just say maximum value. Oh, but I bet you the maximum could be a negative 2. Crap, I didn't even think about that. Well, let's just put 0 for now, which is going to be wrong, but let's put 0 for now. Put current. So I'll say, for this, I'll say current equals maximum of 0 and current plus num. And then I'm going to say maximum value equals max of maximum value and current, and let's try that. So theoretically, I don't have to worry about the yeah, okay. So let's say these three are gonna run and they're gonna work because I don't have to worry about the negative space. But I'm having a very strong feeling that this is gonna have a negative space situation. Yeah, which is here. So what I can do is I can set it up as the OG. Let's see. Is num's always gonna... Okay, thank God. I hate those silly problems where it's like, what if we give you an empty array? Like, bro, no, stop it. Okay, so instead of that, we can do this. See, does that work? Shoot, no. Oh. Alright, nice. Okay. That one was pretty quick. It's just maybe... I'll take a gander at the second one, because I was like... I don't want to make this a 3-minute video. Oh, my maximum jump length. Okay, this is interesting. Now, how do I greedily solve this? Without going into DP territory. I'm trying to think. I'm actually curious to see what the runtime is for this. Oh, then, okay, so just linearly pass it. It's my maximum, which doesn't mean I have to take it. This makes me want to like cache. Which if I cache, it just becomes DP, no? Can I do DP and greedy? So they're Or disjoint. I don't think I don't think I'm allowed to. Yeah, exactly. Exactly, yeah. But oh, we're in the lane. Okay. And so I'm guessing at each thing we have to take the goal. Type shoot. Okay. That actually makes a lot of sense. I wish I thought about that. I want to see if this works as I expected to work. 0, 1, 2, 3, 4. All right, beautiful. Yep, that's as expected. So I'm gonna say. I'm gonna say distance equals 0, and I'm gonna say distance plus equals 1. This is the distance from the goal. And then I'm gonna basically say do I really need the goal, or do I just need the distance? I mean, what's the goal gonna do for me? Maybe I don't need the distance. Maybe I can do index plus, like nums of index is equal to goal. Then we're good, right? What's the problem here? Why is that? Why is that not indenting? Did I do something? What's the invalid syntax? Am I not like add in? Why am I doing it wrong? What? What? What is going on? Huh? Oh, if. Dude. Brother. Come on, man. We're supposed to be a programmer. Alright, cool. I'm just gonna say goal equals nums of index. And I'll just say if goal is equal to 0, then return true. Else, return false. Shit. Oh my goodness. No wonder. Equals index. Yeah. Getting that on the wrong foot there. There you go. See if that works. Wrong. Shoot. I have to put greater than or equal to, because the maximum. There you go. I beat it. Of course, forgot the greater than or equal to part. That is fascinating. That's a very cool problem. I had no idea that would be greedy, but yeah. Should we look into a third one? I think it just depends on how easy this one. Initially presented nums of 0. Each element, nums of I, represents the maximum length before jump from index I. In other words, if you're at nums I, you can make a jump to any I plus j where... Okay. I'll return the minimum number of jumps. Okay, so now I don't need to check if it's true or not. We just need to get the minimum number of jumps. Which is interesting. See, this feels like DP. So they're generated in a way where you can always reach the end. Which makes me wonder, like, okay, we should always just take the biggest jump touch. That might not always be the case. How do you figure that out? Yeah, I have no idea. Again, I'm gonna use some help. Oh, in? Yeah. Yep. That's interesting. That's linear? Okay. So we kind of iterate through until we find the largest. So I'll just say largest equals nums of L. And then for index and range of L plus 1 to R plus 1, largest equals the maximum of largest, and nums of index plus index. And okay. Then I'm going to set L is equal to R plus 1 and R is equal to largest. Is that right? I feel like I kind of like quickly jolted through that. That's not gonna change much, is it? I don't think that's correct. I think this is incorrect. But we'll get the truth once we submit this. Yes, okay. The minimum number of jumps to reach the last index is 2. Jump one step from index 0 to 1. I see, I think I'm doing this wrong. Instead of, I think instead of getting the largest index I can jump to, I need to see the largest index I can access. Which that's a lot of checking. It's gonna hurt my head a little bit. Interesting. I feel like that's my understanding of what he's saying is wrong. My understanding is we just go to the farthest index we can get to. But I think that's incorrect. Because if you look at this one, the farthest index this one can go to is, well, this one, right? Yeah. I'm just looking at the biggest jump you can take. I'm not looking at where I'm jumping to. No, I'm actually pretty confused on this one. Because what I'm thinking is like n squared. It's like, maybe we find the largest. Yeah, I don't actually know. I'm kind of wanting to give up because I don't want to be too long because I gotta get off this pretty soon. Recursion. DP, which is what I was thinking. DP. BFS. Huh. BFS. Really? BFS. Are we looking at like the deepest we can go with BFS? Is that what this is? I guess you could set up like a tree of all the possibilities you can go to. Alright, let's see if we can kind of draw out the idea for this. So we go with this one, yeah. And from here, we go It feels pretty open to me. Yeah. I think I'm gonna do this differently than how he told me to do it. We'll see how this kind of goes. I'm gonna say current equals 0. If it's greedy, then we can take the most greedful solution at each point. So I don't have to worry about like a dip to a high. I should not. I mean, it's greedy, right? I assume that's the case. Whew. Okay. can honestly put the current inside the range, but you know, we do what we gotta do. We just we don't be thinking. Okay, now we need to get a new largest. I'm gonna say I think. Okay, I don't have to worry about that then. I'm blanking right now. I had it, but I just kind of got distracted for a second. We want to find the largest total. I'm going to store that as like index. I guess what we can do, we could just say if largest plus nums of largest is less than index plus nums of index. Then that largest will equal index. And then afterwards I'm going to say current equals largest. Then I just return step. This feels like I'm doing too much. Runtime error. That's because comparing two different types of data. Still got the same thing, man. More. What's this problem? Run it back. Too slow. It feels like it's way too slow. Like we're about to do a time limit exceeded. If we time limit exceeded, I'm probably just gonna copy and paste. We took that long to fail on the fourth problem? What the fuck are we talking about? Alright, bro, what are we doing? I'm a tinge lost, I'm not gonna lie. I'm a little bit confused why we're in an infinite loop right now. Well, maybe I need to take a second to like look at the problem a little bit more carefully. What's going on here, you know? So if nums of 0 plus 0, this is 1, this is greater than or equal to length of nums minus 1, which is the index, then we can break. I see. Silly, silly, silly. Oh, no, that'll do it. There you go. Well, that beat it. Nice. I thought I wasn't going to get to it today. Okay, cool. There you go. Nice, nice, nice. All right, well, 7:42 has been about, what is that, 50 minutes or so? Got 3 done, so it's pretty good. Well, thank you for watching. Yeah. That was that today. Kind of quick and easy. I got to get on with my rest of my day. But I'm glad you stayed here to watch, and I will see y'all tomorrow.